here. Today I'm going to be doing something a bit different. This is technically not related to algorithmic programming, but still it's about coding, so I guess it counts. As you can see here, it's about Manifest v3, and if you have no idea what that means, well, that means you're probably not a Chrome extension developer. But don't worry, I'll tell you all about it and why I hate it. Well, just like one part of it. It's like okay. So if you don't know, I recently published a Chrome extension. It's basically a site blocker, but you can also temporarily unblock sites if you actually have a good reason to go on it. And it has 12 users. Wow. Well, why does this even matter? Well, Chrome recently released, I recently discovered that there's something called Manifest v3, and it was done for a bunch of privacy issues, and I'm not going to go into that, but basically Chrome decides that this thing is really important and that everyone should do it. They even outline a timeline of how Manifest v3 is going to roll out. As you can see, by 2022, you can't publish any more Manifest v2 extensions, which was the old way of making them. And by 2023, MV2 extensions will no longer be available for downloads. That's kind of sad because I just made my extension and it was an MV2. And being the non-procrastinator that I am, I decided to change it to MV3 like last week. So pretty early in the grand scheme of things. Now, most of it went pretty smoothly, except for this tiny but pretty significant part, which is that background pages are completely replaced by service workers. And sure, you might be like, wow, why is that bad? You could just use service workers for everything. Well, they come with a bunch of downsides. One of them being that they don't persist between invocations, which means that once they do a task, they could just die, and you wouldn't know that it died until it gets revived later on. And it's not great if you want to do things like set timeout, which is used heavily in my app. And if you're wondering why I can't do set timeout in service workers, it's because that if the service worker dies, the set timeout dies with it. So the service worker decides to just destroy itself before the set timeout gets run. It'll never get run, and whatever task was supposed to be performed never gets done. And that basically breaks the entire extension. So what did Chrome suggest about this? Well, they said, hey, just move to alarms, because it's a thing that we have. And what do alarms do? They basically do the same thing as set timeout, except that it's kind of bad. Why? Well, Chrome has a bunch of limitations on alarms that weren't previously present in set timeout. One of them being that you can do it at most once every minute, so you can't go to the precision of like a few milliseconds, which is what set timeout can do. And the thing that really gets me here is that Chrome may delay them an arbitrary amount more. That's like saying to your alarm clock that you want to set an alarm to wake up at like 6:30 a.m. But then the alarm clock goes no, I would, but I might also not. So you might actually get your alarm at 7, or maybe you'll get it 4 hours later just because I feel like it. So that's kind of really bad here. And you know what else is bad? You can't set an alarm to be less than a minute, which you could easily do with set timeout. So with all of these things, who would even want to use Chrome alarms? So if we aren't going to use Chrome solution, we need to use a custom solution. And this honestly took me forever to think of, a week. So what you see here is the structure of a basic Chrome extension. We have the service worker here, which replaced the background page from before, as well as a bunch of content scripts and a pop-up script. Now, all of these content scripts, they're initialized one per page. So this is for one tab, this is for another tab, and so on. And these get initialized when a tab opens, and they die when the tab is closed. The pop-up script here is basically the same thing, except it's for the pop-up. Now, the good thing about these is that they're persistent. So, as long as it hasn't died yet, you can do stuff with it. But the issue is, like the service worker, you don't know when these things are gonna die. So, we might be in a bit of a issue here, right? Like, if none of these could possibly guarantee to be alive, where are we gonna put the set timeout? Where are we going to make sure that we have a persistent script here? So my first instinct was to just say, let's see if we can make the service worker invincible and just keep it from dying. It turns out you can't. You could probably postpone it by like 5 minutes by doing something like wait until, or you can just have a bunch of stuff send requests to it. But like, even with that, the service worker will still die eventually. And sometimes even, I found this on Stack Overflow, but even if the service worker is actually doing something, if Google Chrome thinks that it's using processing power maliciously or something, it could just kill it. So there's no guarantee that the service worker will stay alive. Another thing I tried here is to set an alarm that goes off every minute to constantly revive the service worker. But the problem with that is that if it dies like a few seconds after revival, the user has to wait another 55 seconds before stuff can actually get run. Now you might be asking, how did I solve this issue? Well, there's actually a missing piece that I didn't tell you. That's that there is something called Chrome.storage. Alright, now what is Chrome.storage? Well, it's basically like a place where you can store data and stuff. But here, I'm not going to use it to store data. No, I'm going to use it to store whether or not the service worker is still alive. And these scripts here, they're all going to be listening to that one thing. And if they determine that the service worker is dead, any one of these brave souls will venture out and revive the service worker by sending a message to it. And that way, we'll have basically instantaneous feedback. With like, as soon as the service worker dies, one of these scripts will revive it. So basically, it's as if the service worker never died. And you might be wondering, well, aren't the set timeouts killed anyway since the service worker dies? Well, good question. I actually added some more code so that when the service worker does get revived, it actually resets all of those set timeouts so that they could get run again. And that basically allows for everything to work just as it would have worked before. We can make sure that only one of these scripts actually pings the service worker by checking which one is focused right now. Since all of these are from tabs, only one tab can be focused at once. So only the script from the focus tab is responsible for reviving the service worker. And if the pop-up script is open, well, only the pop-up is focused. So that will revive the service worker. Boom! This is like a complete loop here. And it works. I've tested it. Oh, and also a thing I forgot to mention is how does the service worker indicate to the scripts that it's still alive? Well, basically every second or every half second, it just puts out the current date in Unix time into like a storage slot in a local storage. And then the scripts see that and they're like, oh, the service worker is still alive. So it doesn't need to ping it. And that is my workaround to this thing. And it's much better than Chrome.alarm since you can still use set timeouts and you get all the benefits of a service worker, which are that you can use it in manifest v3. That's about it. So thanks for listening. We'll see you next week for CoVidLog number 3.